rotational motion. Is going to be rotational motion. Find out when object is rotated around axis called rotational motion. Consider a case where an object rotates on O-axis. This rotate uniformly. Right. Draw the diagram. Let me take there's points P and Q. Let's take this point as P and this point as Q. Right? P and Q. Draw this one. And write down the particles in rotating axis. The particle in rotating axis are in rest. All the other particles of an rotating disk, all the other particles of an rotating disk moves in circular motion. Right. When it rotates the rotational motion, the all other particles every particle having uniform angular velocity, uniform angular acceleration, uniform angular displacement. All particles are getting like that. Right now, all other particles are having same angular displacement, same angular velocity, same angular acceleration. That means angular displacement in theta, angular velocity is omega, angular acceleration is alpha. That means that the parameters we previously discussed. Right? Right. Let me take this example. When it rotates in rotational motion, the axis is O. Right? Therefore, when it rotates around the O axis, let me take the P and Q particles. I am looking in upward direction, right? From the up. When it rotates, P rotates in this direction, Q rotates in this direction. P and Q are having a circular motion. Right? Therefore, P and Q are in circular motion. See, if it rotates the angle theta, P also rotates in angle theta, Q also rotates in angle theta. That means angular displacement theta, right? Right? Angular displacement theta. When P is moving angular velocity omega, Q also moving angular velocity omega, right? Omega same to each other. Alpha means angular acceleration. If it move in angular acceleration, it also move in same angular acceleration. It also move in same angular acceleration, but the center always it is in rest, right? All other particles are moving same angular acceleration, same angular displacement, same angular velocity, right? Okay. Then write down. Radius of other particles. Radius of other particles. Radius of other particles. Radius of other particles are getting changed. Therefore, distance on the radius, distance on the perimeter, S, distance traveled in perimeter, S, tangential velocity V, tangential acceleration AT, radial acceleration AR, getting changed. Right. What is that? In circular motion we discussed. What are these? S means the distance traveled on the perimeter. That means this one. Distance traveled means this distance. It is different to particle. See, it traveling like this. Therefore, we can in circular motion there is a formula called S equals R theta. V equals R omega. R is getting changed. Therefore, if there is a same angular velocity, but the tangential velocity are different, right? Because the radius are different. AT mean tangential acceleration. What is the tangential acceleration? Formula of the tangential acceleration. AT equals R alpha. That also differs. Why? When it travel, the alpha, the radius of the particles P and Q are different. Therefore, alpha AT equals to R alpha. Then the radial acceleration AR equals V omega or V square over R omega square. It also changed. Why? It also changing because the radius is changing. See, the radius is changing. The difference. These are changing parameters. Right. Right down. Previously we discussed in the circular motion what are the parameters. Right. Then write down. Write down the equations. Write down the example. Take example. Then write down the example. After the starting the switch of the fan, after the starting the fan, it get accelerate, it get accelerate, it get accelerate. 5 RADS minus 1, 5 RADS minus 2. Alpha equals 5 RADS minus 2. S minus 2. When it reach omega equals 10 RADS minus 1, 10 RADS minus 1, 10 RADS minus 1. When it reach 10 RADS minus 1, find the tangential velocity. Find the tangential velocity. Find the tangential acceleration. Find the tangential acceleration. Find the radial acceleration. Find the radial acceleration. Right. Fine. Previously we discussed in circular motion what are the parameters. In this case also they are the parameters. Find the parameters. We know the formula. What is S equals RT, V equals R omega. We want to find the V. Therefore, V equals R omega. R means 10 centimeter. That means 10 to the power minus 2. Omega means 10. That means 1 ms minus 1. Right? Therefore, what is the radial acceleration? This is tangential acceleration. Tangential velocity. Tangential acceleration means AT equals R alpha. R means 10 centimeters. That means 0.1 meter. Alpha means 5 R radius minus 1. Therefore, 0.5 ms minus 2. Then we have to find what is the radial acceleration. Radial acceleration means AR radial acceleration. These are the parameters which we are discussed in circular motion. AR equals radial acceleration. So radial acceleration AR equals V omega or omega square R. I am taking the omega square R. Omega square means 10 square. R means 0.1. That means 100 into 0.1. That means 10 ms minus 2. These are the parameters. Radial acceleration, angular velocity, tangential velocity, tangential acceleration, and the radial acceleration. Right. Then, okay, උත්තරය හරි. හොඳයි. Then write down. Consider an object. Consider an object rotating with a uniform Consider an object, write down. Consider an object is rotating, with uniform angular acceleration alpha, let initial angular velocity omega naught, the final angular velocity omega after simple t time, angular displacement is theta, and the angular acceleration is alpha. Angular acceleration is an alpha. Angular acceleration is alpha. Right. We know there is a four motion equation for the linear motion. Right. Four motion equation for the linear motion. This is also modified. There is an equation for rotational motion. They also get it from the from the linear motion. It's very easy. Write down. There is motion equation which using rotational motion. This equation modified using the linear motion equations. Right. It is very simple case. We know what are the linear motion equations. We consider linear motion. Rotational motion. What are the equation for linear motion? What are the parameters? We know linear motion when object started its motion with u and finish its motion v, t equals to 0 to t equals t. The distance traveled is s. The acceleration is a. We can take u as initial velocity, v as final velocity, s t as time, S as displacement, linear displacement. A as acceleration, linear acceleration. In circular motion, we know what are the equation. There is four equation. V equals U plus AT, S equals UT plus half AT square, or S equals U plus V, U plus V over 2 into T, S equals UT plus half AT square, V square equals U square plus 2AS. There are four equations. We have to simply modify it. We have to apply simply say U as omega naught, V as omega, T as T, displacement A S as theta, angular acceleration A as alpha. Then we can say V means omega. Omega equals U means omega naught. Omega naught plus A means alpha. Alpha T. S means displacement, angular displacement. Theta equals U plus V. That means omega plus omega naught plus omega over 2 into T. Then S equals UT plus half AT square. S mean theta equals omega naught T plus half AT means alpha T square. Then V square equals U square plus 2AS. That means V square means final velocity omega square equals omega naught square plus 2 alpha theta. These are the equations. These are the equations we are using in rotational motion. These are the equations we are using in rotational motion. It can be get used in the circular motion, the linear motion, right? Write down, write down this table. Write down this table. It's like a linear motion equations. There is no difference. It's like a linear motion. Linear motion, the application of the motion equation are very easy. Therefore, this also very easy, right? Only the difference is the initial velocity and the final angular initial linear velocity is equals to the linear angular velocity, initial angular velocity. Final linear velocity equals to final angular velocity. Time equals to time. Like that, in the rotational motion, we can use this motion equation as before we use in a linear motion that we had used. Likewise, we have to use, right? Right now, is that finished? For these parameters, you have to again go through the what angular circular motion. After you go through the circular motion, you can, if you don't know these parameters in the circular motion, we discuss the parameters. Okay, is that finished?
Yes, sir.
Write down the example. There are so many examples we have to do. Write down. Write down. When an object which rotates, when an object which rotates with angular acceleration alpha, angular acceleration alpha equals 4 RAD minus 2, 4 RAD minus 2, and increase in omega naught 8 RAD, and increase in omega naught to 8 RAD, S minus 1 to omega 10 RAD S minus or 16 RAD S minus 1. The alpha is equal to the 4 RAD S minus 2. Find the time taken to find the time taken. Find the time taken. Write up quickly find. It's very easy problem. Only apply this equation. Right? What is the answer? We know omega naught, omega alpha. We have to find the t. Omega equals omega naught plus alpha t. Is the equation. What is the answer? The answer is omega equals to the 16. Omega naught initial angular velocity is 8 plus 4 into t. That means it is 8 40. T equals 8 over 4. That means 2 seconds. That means 2 seconds. Right? Then write down another example. Write down another example. When an object starts its motion at rest, and having alpha equals 5 RAD minus 2, and having angular acceleration alpha equals 5 RAD minus 2 in 10 seconds. Find the omega naught equals 0 and find the final angular velocity. Find the final angular velocity and get omega and angular displacement theta. Angular displacement theta. Right? Write down. Okay. There. What is the equation? I have to use. We want to omega. That means we are knowing these things are. Then we can apply the first equation. Omega equals omega naught plus alpha t. That means omega naught t equals 0 plus alpha means 5, t means 10. Omega equals to 50 RADS minus 1. Right. Your answer is correct. Okay. Then we have to take the theta. How to take theta? Theta means we can use this one. Eh? Third one. Third one. Okay. We can use the third one. That means theta equals omega naught t plus half alpha t square. Okay. Omega naught means 0. 0 plus half. Alpha means alpha 5. T square. T means 10 square. 10 into 10. That means 5. 10 into 10. That means 25. 25 into 10. 250 radian. Your answer are correct. Right. Good. Then very small case. We have to use the constant equations. Right. Then write down another problem. When an object rotates, when an object rotates with angular acceleration, with angular acceleration, 4 r radius minus 2. 4 r radius minus 2. Alpha equals 4 r radius minus 2. 4 r radius minus 2 and increases its rotational speed, 200 rpm to 1000 rpm 1000 rpm. Find the time taken. Find the time taken. Find the time taken. Find the total. Find the total angular displacement. Angular displacement. Find the total rotation. Find the total rotations. Find the total rotations. Right. Let's get Okay. Find values to the omega value. How to change the n values to the omega values? Omega is the rotational speed. Therefore, we have to take this equation omega equals 2 phi n. N is the, when n subtract in RPS, we can get omega RAD S minus 1. Correct? How to convert the RPM value to RPS value? RPM value to RPS value. RPM means revolution per minute. Revolution per minute. If an object is revolution per minute is 120, what is the revolution per second? RPS. That means 120 divided into the 60, right? We have to substitute that thing. Then, in this case, N naught. N naught equals 200 RPM. That means omega naught equals. Therefore, we have to divide it into get the RPS value 60. That means 10 over 3 RPS. Omega equals to omega naught equals to what? 2 5 N naught. N naught means 10 to 10 over 3, 25 over 3. That's the value. Likewise, we have to take the N. N equals 1000 RPM. 1000 over 60. That means 50 over 3 RPS. That means omega equals 2 5 50 over 3 105 over 3. Right? Then alpha is given to 4 radius minus 2. Therefore, we can find the rotations. Total rotation 200. Right. 209. Let's see. We have to take the omega. First of all, we have to take the time. How to find time? We know omega, omega naught, alpha. Therefore, we can use the omega equals omega naught plus alpha t. V equals u plus at. Right? Like that, 25, sorry, 105 over 3, 25 over 3, plus alpha means 4 t. That means 105/3 minus 25/3, 40, 85/3, 40, T equals 25/3. That means 20 into 3.14 into 3, right? That means 20 into 1.0 0.4. Likewise, 10 to the power 4, 10.4 into 2, again 20.8 RID. Right? See, is that correct or not? Time is 20 point. Okay, your answer is correct. Right. Then we have to take the rotation theta. Theta equals, how can we find the theta? If you know the time, we can simply substitute that them, or we can use the omega square equals omega naught square equals omega naught square plus alpha d. That means b square equals u square plus 2as. B square means omega square equals u square means omega naught square plus 2 alpha theta 2as, right? That mean omega square. What is omega square? Omega square means this one 105/3 square. Omega naught square 25/3 square plus 2. Alpha means, what is alpha? Alpha is 4 into theta. That means we have to simplify this one. We can simplify like this. 100 means 10 to the power 4, 5 square minus 400, 5 square over 3, 2 into 4 into, that means 8 into theta. 8 into theta. What is the value? 10 to the power 4 means 10,000, 10,400, 9,600, 9,600, 5 square into 3 into 8 equals theta. This is the number of, this is the angular displacement. Then take the value. Yes, your value is what? Good. Then number of revolution. Number of rotation or revolutions. What is it? This is the theta value. Theta over 2 pi. Why? Because if we consider one rotation, theta is equal to the what? 2 pi radian. Therefore, we have to divide it in 2 pi. Radian divide 2 pi. Okay. 209 rotations. Good. Okay. Then there is a method. In this case, we are using the general equations for the rotation, but we can take rotation in one equation, right? Using one equation, there is a small method, right? Write down. It can be directly used. It can be directly used. Rotational values. Rotational speed values. Rotational speed values. Instead of omega. Instead of omega. When using the rotational. When using the rotational speed. Following changes should be applied. We can use the rotational speed as follows, right? When angular speed. What is angular speed? Omega. For that, we can use the rotational speed. Rotational speed n. What is the unit? We can simply modify these equations. Unit RAD s minus 1 RPS. We can modify this equation to get the rotation in one equation. Okay, in one we can take the rotational. We have used the rotational value. Then we can in one equation we can take the number of rotation. Let's take angular velocity speed, rotational speed, right? Therefore, alpha angular acceleration, alpha, we have to take the units RAD s minus 2, but in the rotational motion, rotational angular acceleration, we can take revolution per square seconds. Revolution per square seconds. Angular displacement, that means angular displacement means radius. In the rotational motion, we can get number of rotations. Number of rotations. Right? Reading rotations. Units and their rotations. We can simply modify these equations. Omega naught t, omega equals omega naught plus alpha t square. We can modify n square equals n naught square plus alpha t. Theta equals omega naught plus omega over 2 into t. We can modify theta, revolutions, number of rotations, let's take as theta. Theta equals n naught plus n over 2 into t. Theta equals omega omega naught t plus half AD square. We can simply modify theta equals n naught t plus half alpha t square. Then there is equation omega square equals omega naught square plus 2 alpha theta. N square equals n naught square plus 2 alpha theta. Right? We can use these equations. Right now, let's do this problem in this method. Right? It is very easy in using this one, but you have to remind these methods, and both methods are easy, but the previous method is very easy, not easy, very useful to every cases. Right, right up. Then let's we do this problem previously. I discussed it is in one method. So again I discuss in these methods. Previously the problem there's a we have taken consider the time and number of rotation. So this case we have to get it into the units. N naught equals to 20 over 60 RPS. How to transfer the RPM value to RPS value? RPM value means revolution per minute. We have to divide into 60 to get the revolution per second. Then N value, N equals 100,000 over 60. Right? That means so 10 over 3 RPS, 50 over 3 RPS. Right? Alpha we have to convert to revolution per second square. There is a radius. Alpha means alpha in 4 RAD S minus 2. We have to convert the radius, we have to convert the radian values to the revolution value. How to convert the radian value to revolution? We have to divide it into 2/5. Why? We have to divide it into 2/5. When we are getting the radian value, they take radian 250. We have to take the rotations. We have to divide it into 2/5. Why? The full circle means 2/5 radian. Right? 2/5 radian. Likewise, we have to divide it into 2/5. Alpha means 4 over 2/5 radian. That means revolution, converting the revolution. S minus 2. 4 over 2/5. All the values are okay. Then we have to find the t. Let's find the t. What is the equation? Equation means this one is better. N square equals N naught square plus alpha t. That means another method we can take the 50 over 3. N naught means 10 over 3. Square of that plus alpha means 4 over 2/5 into t. That means 50 square minus 10 square, or we can take the subtraction of the difference between the squares. Right? 50 plus 30 or that's the simplification of 10/3 square 4t/2 5. Find the value. That means 60/3 into 30 40/3. Difference between these squares, huh? There is no another. That means we have to simplify, or you can using the simplification method anything you can take the value. It is, if it hard, I am using 2,500 over 9 minus 100 over 9. Simplify this one. We can take we can take 2,400 over 9 40 to 5. We can take T as 80. What is the T value? I think it should be the previous value. It should be the previous value. So for this case, previously I wrote that equation wrong, right? Omega equals omega naught plus alpha d equals n equals to n naught plus alpha d square. Alpha d, right? That like that. We have to take the n naught value, n value, then we have to substitute this one to get the t value. N equals 10/3, n naught equals 10/3, n equals to 50/3. Therefore, the alpha equals 425. Why we are dividing like that? 4 is the radian value. We have to divide it into the 25 get the revolution value. Therefore, after that we take the t value. Then number of rotations mean the number of rotation. How can we get the number of rotation? We have to get the equation n equals n naught square plus 2 alpha theta. Right. From this equation, n equals to the 50/3, n naught equals to 10/3. 2 into alpha means 4/25 theta. Therefore, we are substitute. Then we get the number of rotation. Write down. This is the simple method. Right. Write down the problem. Write down the problem. Only one problem. Write down. A rotational wheel. A rotational wheel increasing right. This is simple method. This is simple method. I think mic is not connected. No? This is simple method. We have to use this n naught n values to get this equation, and we can convert to rotational motion. Rotational. These are rotational equations. So we can get the this equation to get values, right? Like this. Then write down the problem. Write down the problem. Another problem. A rotational wheel increasing. A rotational wheel increasing its rotation from its rotation from 120 rpm to 120 rpm to 360 rpm 360 rpm 360 rpm with 600 rotation. With 600 rotation, find the with 600 rotation, find the angular velocity of the rotating wheel. Find the angular acceleration of rotating wheel number 1 with units radius minus 2. Number 2 with unit revolution per square seconds. Revolution per square seconds. Right? Revolution per square seconds. Right now, find the problem. In this case, we have to use the values as when we using this method, we have to substitute this. We have to change this one RPM to RPS, RPM to RPS, then radius minus 2 to revolution per square second. Therefore, after that, we are getting theta as the number of rotation. T is very easy, right? Do this, do that problem in 2 cases. Both cases we can do. Right. What is the answers? A rotating wheel rotates omega naught 120 rpm. Not omega, n equals to 360 rpm. Theta equals to 600 rotation. What is the alpha? Right. Find out. Right. What is value? We have to find using, first of all, we have to find using normal equation. We have to convert the omega n into the omega. Then we can find the simply we can find the alpha in radius minus 2. Then find the alpha using the RNA revolution per square seconds. Revolution per square seconds. Find the value. What is the answer? What is the answer? In this case, first case we are using we are converting n naught equals 120 rpm to rps divided by 60. 120 divided by 60. That means 2 rps. In values 600 rpm. Sorry, 360 rp. M 360 over 60. That means 6 rps. 6 rps. Then we can take the omega naught value equals to 25 n naught. That means 25 into 2 45 rad s minus 1. N means omega equals 2 phi n. That means 2 phi n means 6. 12 phi RAD s minus 1. Then we have to find this okay, this okay. Then we have to find the theta. How to find the theta? Theta is rotation. Theta is rotation. 600 rotations mean 2 phi into 600. Right? That means phi radians. 1405 radians. Right? Then we can apply alpha. How to find alpha? Omega square equals omega naught square plus 2 alpha theta. Omega square means 12 phi square of the 12 phi. Omega naught square is square of the 4 phi. 2 alpha means we have to find, theta means 1200 phi. Then we can find simplify this one, this 12 phi square 4 phi square. Right? Square. 12 phi square minus 4 phi square. That means what? That means 12 difference between the squares. That means 8 phi 4 phi. Today very easy. Right. Then we can phi and this is 300 alpha equals to 4 phi alpha equals to 4 phi over 300. The value is 0.41 into 10 to the power minus 10 to the alpha can be taken as 0.167168 RAD s minus 2. Then using the previous, I told there is a rotational equations. That means n equals to with RPS what 2 RPS, n naught equals 2 RPS, n equals to 6 RPS. Then theta equals number of rotations 600 rotations. Alpha. We have to take the alpha. What is the equation? N square equals n naught square plus 2 alpha theta. It's very easy. N equals 6 square. N naught means 2 square. 2 into alpha into 600 rotations. That means 36 minus 4. 120 to the 1200 alpha. Alpha equals to 32 over, right, alpha equals to this one. This is 32 over 0.0267 revolution per square seconds. How to convert the revolution per square seconds? We can convert revolution 0.0266 into revolution. Revolution means we have to multiply it by 225. We can get the radian value. If we multiply 25 over RAD s minus 2 s2 square, that means 0.266 into 25. Yes, we get this value 0.168 RADS minus 2. Right. Okay. Good. Huh? Right. Then write down when object is rotating with uniform angular velocity, rotating with uniform angular velocity, alpha is 0, therefore
per second, square second.
then when an object rotating with uniform angular velocity in linear motion, what is the equation for uniform velocity? We know S equals UT. Rotational motion, S means theta, U means omega t. There is equation theta equals omega t. Write down. Right. Write down the problem. Write down the problem. When a rotating wheel rotate with 15 radius minus 1, rotate with 15 radius minus 1, uniform velocity find the angular displacement. Body का theme है. Find the angular displacement. Here. Let me. Right. What do you guys have? Theta equals omega t. What is the angular velocity? 15. 15 into t equals what is time? 6 seconds. I told angular velocity 5 eh? Omega equals 5 RADS minus 1, t equals 6 seconds, therefore 30 radians. Right. Write down another problem. A rotating wheel rotates with 1200 RPM. Find the rotations. Find the rotations in 10 seconds. Find the rotation in 10 seconds. Find the rotations. It's rotating 1200 RPM. Find the rotations. What are the rotations? We have to get the RPS value. To that, we have to divide into 60. 20 rps. Therefore, we have to take the omega value 25. N is 20. That means 45 RAD S minus 1. Theta equals omega t. It is equals omega t. Omega equals to 405. T equals to 10. Right? That means theta equals this one. Then number of rotations. We can take 405 over 25. That means 5 minimum 200 rotations. This also can be done using the previous method, the rotation equations. How can we find that thing? We can tell omega into n. Therefore, theta into rotations. How can we take that thing? Theta equals omega t. Theta means rotations. Rotations, theta. Omega means omega means 20 rps. This value should be rps value. This is seconds. 20 rps into time 10 seconds on 200 revolutions. Rotations. Like that, it is very simple. It is very simple. Rather than this one, it is very simple. Write up that thing also. Then it's very easy. Then write down the topic. Motion graphs. Write down the topic. Write down the topic. Motion graphs. Motion graphs. We can again, if that's why two columns, because the linear motion graphs are much similar to the rotational motion graphs. Let's take linear. For that, when linear motion, first graph is what? ST graph. That means displacement time graph. Displacement time graph means S in meter, time T in seconds. Therefore, we can take like this. This is delta S, delta T, delta S, delta T, gradient equals tan theta, delta S or delta T. That means velocity. Linear motion we had discussed like this, right? What are the changes of rotational motion? Rotational motion, the displacement time graph can be taken displacement time graph can be taken as number 2, number in this case angular displacement time graph. Angular displacement time graph. For that, we can take theta radians, t seconds, like this. Theta, this is delta theta over delta t. That means the gradient equals tan theta equals delta theta over delta t. That means omega. Gradient is equal to the angular velocity. Right. Write down. Write down. Draw the same case for the velocity time graph. Same case for the velocity time graph. What the given the velocity time graph, the gradient is the linear motion, the acceleration. So to the rotation motion right now. Likewise. Right. Right now. We can take the velocity time graph. The velocity time graph, the gradient is delta v over delta t. Delta v equals to the velocity change. The gradient tan theta equals to delta v over delta t. Right? It is acceleration. Why? The velocity time graph, the that gradient, it is acceleration. Right? Acceleration. It is acceleration. Area under this graph is displacement. Why? In linear motion, we got the area under the graph is displacement. Then, uh, then the area under the graph is displacement. There, this one is okay. Likewise, the angular velocity time graph is also the same, and the gradient of the angular velocity time graph, angular acceleration, linear acceleration, angular acceleration, right? Area under this omega t graph, area under the omega t graph is angular displacement. Like this is displacement, linear displacement, this is angular displacement. Likewise, the both cases are same. You should have to memorize the linear acceleration, and then you can get the angular acceleration, right? And then you can get the rotational motion. Linear motion and the rotational motion, both are same, right? Both parameters are same. You have to memorize what are the similarities of these cases. In 2020 treat. There is a 50 MCQ 51. It got the rotation motion, right? Rotation motion very important, right? In the previous examination 2025, 2024, it got the rotation motion, right? Rotation motion. So in your examination, there will be problems in rotation motion. The MCQ problems can be rotation motion. So you have to memorize what are these and how to get the you have to do the all the past paper problems, right? In this case, there are so many past paper problems, and I will give the my tute also, right? Okay. Then write after the after this. Then write draw theta t omega t alpha t graphs to uniform angular velocity. How to draw the theta t, omega t, alpha t graphs to uniform angular velocity. Write down. Draw quickly. Uniform angular velocity. Draw the graphs. Draw the graphs. What is the uh, motion graph to uniform angular velocity? Uniform angular velocity means the gradient of the theta t graph gives the angular velocity. Gradients are uniform, therefore this is the uniform angular velocity. And omega t diagram means uniform angular velocity means angular velocity in uniform state. Right? It is like this. Alpha t means uniform angular velocity. There is no alpha. Why? If there is a uniform angular velocity, is there any angular acceleration? No, there is no angular acceleration. Any angular acceleration, right? Theta t graph. How can we find the theta t graph? Theta t graph. For the and right. It's okay. Right. Then write down the problem. Write down the problem. Draw the theta t, comma omega t, comma alpha t, graph for uniform acceleration. graph for uniform acceleration. Graph for uniform acceleration. Right? Draw the graph. Draw the graph. After that, you draw graph for uniform angular deceleration. Deceleration. Right. Right now. Draw. In linear motion, acceleration, st graph, how can we draw? In displacement time graph, what is the gradient? Displacement time graph gradient is what? The gradient of the displacement time graph is velocity. When object moving with acceleration mean increase in the velocity. Increase in the velocity. හරි velocity එක වැඩි වෙනවනේ. එතකොට මෙයාගේ gradient එකත් වැඩි වෙන්න ඕනේ. The gradient should be increased. Gradient should be increased. Right. Like this. Gradient should be increased. What is the gradient of the omega t? Omega t graph. What is the gradient? Gradient is equal to the acceleration. Gradient is equals to the acceleration. Which acceleration? Rotational acceleration, right? Angular acceleration. Therefore, gradient should be same. Why? Uniform angular acceleration. Gradient should be same. Right. Uniform. The alpha means uniform angular acceleration. Uniform angular acceleration. There is a value. It is alpha. Alpha in like this. Like that, we have to draw. Okay. Then for this uniform angular deceleration mean the gradient of the theta d graph is what? Gradient of the theta d graph is angular velocity. The deceleration mean angular velocity getting decrease. The gradient decrease like this. Uniform angular deceleration mean omega t graph. The gradient is the omega t graph. The gradient is the acceleration, angular acceleration. Angular acceleration. There is not angular acceleration, angular deceleration. How can we draw? Omega should be getting reduced. The gradient is same like this. Omega is getting reduced. Gradient is like this. Angular deceleration. For this case, this is like this. Right. Right up. Right up.